9.5 is congruence transformations, and problem one, we have a reflection over n following a rotation over 90 degrees about point P of LMNO. Okay, and they're telling you that that equals, so we're going to rotate first to here and then a reflection to here. So which angles have equal measures? So if I rotate it first, if I label these, this is L prime, this is M prime, and this is N prime, and this is O prime. And that helps me to kind of see a reflection, again, flips over that line. Okay, so angle L would be congruent to angle G. Okay, angle M would be congruent to angle H. Angle N congruent to angle J. And angle O congruent to angle K. Again, equal measures now of sides. We do side LM is equal to GM. MN is equal to GK. I'm sorry, not GM, GH. Apologize, got confused a little bit. MN is congruent to HJ. NO is congruent to JK, and OL is congruent to KG. So again, it's in the names. And problem 2, which pair of figures is congruent? Okay, so if we take a look at the triangles, how can I get triangle MLN to match triangle EDF? Okay, the two triangles match each other, 1 to match 2 here. What do? Well, I would say that that would be a rotation of 180 degrees about the origin. It's going to map that, or of triangle DEF is going to equal triangle LMN. Therefore, they're congruent because of that rotation. Well, how do I get the trapezoids to be right? Well, obviously Z and J got to match, because if you look at the lines, that's how that works. So how do I flip it like that? Well, in order to do that, I'm going to have to go ahead and translate it and then reflect. So what I'm going to do is, if I flip it over the y-axis, I'd probably have to do that first. So it's going to be a composition of isometries here. Okay, so what I would have to do first is reflect over the y-axis. Now, how do I get that to match? Well, how do I get y from there to be C over there? I'm going to have to translate it. Well, how am I have to translate it? Okay, I'm going to have to go 1 to the left, and then 1, 2, 3, 5, down. Okay? And then we're going to count up from here. So we translated -1 this way. Now let's count up. 1, 2, 3, 4, 5. So it's up 5. So our translation is -1, 5. Following a reflection of the y-axis. Problem 3 talks about what is the congruency transformation that maps triangle JQV onto triangle EWT. So we're going black one to the blue one. So that's 2. So black triangle to blue triangle. So what do? Well, let's see first. Can you flip it? Do you have to rotate it? What do you have to do? It looks to me like it's a flip. So you can reflect it first, or you could translate it first. Let's go ahead and translate it first, see what happens. So how far am I going to move this up? Let's go up. Let's take Q, and we're going to go up 1, 2, 3, 4, 5 to right there. That's going to make it point. So we're going to translate, and we're not going to move it anywhere left or right. So it's going to be 0, 5. Why am I not going to move it left or right? Because it looks to me like this is going to be my reflection line. Okay, so because it looks to be equidistant from there. So again, we translated it first, so I know you have to write it second. It's weird. Okay, so following translation of 0, 5, what are we going to do first? Let's reflect it over, or second, I'm sorry. We're going to reflect it over the y-axis. Okay, so the transformation is a reflection of the y-axis following a translation of 0, 5. Now, You could have done it the other way. You could have reflected it first and then translated it. It's the same thing. So either one would have been acceptable here.